Let's go and get started on this Exploration 1.7 Text Message Mayhem. So we are starting on the second half of Unit 1. I broke it up into 2 tests, that way it's not so overwhelming. We're going to be looking at what's called piecewise functions in this part of the unit. So let's start at the top. Veronica has a cell phone plan where she pays $29.90 per month for unlimited calls and up to 500 text messages. However, if she goes over her allowance of text messages, she is charged an additional fee of 10 cents apiece. Okay, most of you probably have unlimited texting now. This worksheet is several years old. Whenever I first got a phone, I did have to pay 10 cents a text, and so that added up really quickly. Thankfully, nowadays they have unlimited everything, but we're still going to do this problem because it's a good example of what a piecewise function looks like. If you don't have your calculator, go ahead and pause the video. Make sure you all get your calculator. You need to have it for this exploration. So we're going to create a function and a graph to represent this problem. Veronica pays $29.90 per month for unlimited calls and up to 500 text messages. So for everything up to 500 text messages, she's only going to pay $29.90 a month. So let's go ahead and fill that out. So for 250 text messages, because this is text over here, she's going to spend $29.90. Same thing for 388. Her monthly bill would only be $29.90. And we would keep going until we got to 500. So then once she reaches over 500 texts, which is very easy to do, she has to pay 10 cents a piece. So we would add 10 cents to $29.90 and get 30. So then we need to figure out, well, how many would she have to, or what would she have to pay for 25 over or 150 over? So let's figure out this process starting with 501 text. So regardless, she's going to pay $29.90 a month, but then she pays 10 cents for everyone over 500. So we just multiplied 10 cents times 1 there. Okay, what about the next one? I'd have $29.90 again plus 10 cents times, how much am I over 500? Well, 525 minus 500 would be 25. So then you need to simplify that and then keep going. So I want you to do the rest of these on your own, and then we'll come back and check them. Alright, so for 525, we got $32.40. And then whenever we go up to 650 text, that's 150 over 500. So she would have to pay $44.90 a month. And then for 950 text, she would pay $74.90. And then for 1200 text, which is 700 over the 500 limit, she'd pay $99.90. So you can see that she could rack up a bill very quickly if she goes over 500 text. Like I said, thankfully most of y'all have unlimited and y'all just use Snapchat anyway, so hopefully your parents aren't paying this much for you per month for your phone. Alright, let's graph this. So X is my text, and then my Y would be the total cost of the monthly bill. So we're going to let the X-axis represent number of text. And we have to go from 0 all the way to 1200. So let's just increase by 50 every time. I'm not going to write every 50 just because I don't have enough room. So each one of these little squares is going to represent 50. So you'd actually end up at 1,000, but that's okay. We just won't graph that last point. So I'm going to try to squeeze in every 100 here. Okay, now let's switch and go to the y-axis. So this is my cost, and the most we get up to is $100. So let's just go by tens, and actually it's going to be going by fives, but I'm just going to write every 10. 10, 20, 30. Okay, so take just a little bit of time and number your scales the same. And then we're going to graph these points. So let's start off with 250 text. So I'm going to go to my x-axis at 250, and that costs $29.90. And then 388 also costs $29.90. Okay, so basically we could just draw this smooth continuous line because any amount regardless of the number of texts Veronica sends, if it's below 500, she still has to pay $29.90 a month. Okay, now let's start graphing the other half. So for 525, I would be at $32.40. And then 650 jumps to about $45. $950 is about $75. And then $1,200 would be all the way up here at close to $100. So we can create this smooth line for this part of the graph. So basically what happens is we have two separate graphs going on here. We have this horizontal line, and then we have this linear line that's a diagonal, okay? So let's talk about the domain and range of this relationship. So remember, domain is all of the x's. So what is my least x value? And remember, x is the number of text. So what's the least amount of text that Veronica could send? Well, that would be 0. And then what's the most that she could send? Could she send 10,000 texts? Could she send 50,000 texts? Yes, I hope not, because that would be crazy insane. But there's really an unlimited amount. So this would just keep going to infinity. See, this graph just keeps growing on and on and on. Okay, moving on to the range. Range is our y value, which is our cost. So what is the least amount that this plan is going to cost no matter what? Well, even if she sends 0 text, she still has to pay $29.99 a month, or $29.90 a month. But then, depending on the number of texts she sends, that could just keep growing to infinity. Moving on to number 2. Is this relationship a function? Why or why not? Yes, it is, because it passes the vertical line test, and there's also no repeating x's. Number 3, what function can be used to relate the monthly bill to the number of text messages when x is greater than 500? So let's look at this part right here that I'm highlighting in red. We are going to create our own function to represent this. So we have this data, and we need to figure out an equation to represent it. So I know that y is my cost, and we pay $29.90 a month just to get the cell phone bill. And then we pay 10 cents for every amount that we go over 500 text. And remember that x represents the number of texts. So what would I have to do with x in order to represent x over 500? Well, just like what we did up here, if I had 525, I had to subtract it from 500 to get 25. So we would just take our x and subtract it from 500. So here's our equation to represent this data. Moving on to number 4. Explain why this function cannot be used for values of x between 0 and 500. So why could we not use this function for any text between 0 and 500? Because what would be the cost of our bill if our text is between 0 and 500? It would just be y equals $29.90. Because when x is between 0 and 500, we only pay $29.90. Alright, so that was just an example of when piecewise functions are used in the real world. Businesses use this math all the time. Like, for example, Chick-fil-A. There's so much math behind the demand for their chicken nuggets and french fries. You know, whenever you go through their drive-thru, they're so efficient because they know exactly how many chicken nuggets they need for that day. Not exactly, but there's math behind it about they know how many chicken nuggets or how many french fries they'll need for that day. And so anyways, this math of creating functions based off of data is used in several different businesses every single day. Okay, go ahead and look at your practice. If y'all need to, pause the video and pull up your Chromebook and go to Google Classroom and then click on the assignment Practice 1.7 Absolutely in Pieces. Should look like this. So I want to go over the first 2 questions with you. We're not actually doing notes over this today, but I think you could go ahead and start this paper. We'll take notes over piecewise functions tomorrow, but that's why I want to do the first 2 problems together so you know what to do. Okay, also remember that on Google Slides you can do insert, line, and then scribble in order to create a graph, which is what we're going to do down here on number 1 and 2. So the first thing you need to do is go to your calculator and create this new graph. We need the square root, not the square root, the absolute value of x divided by x. And remember that if you hit the button to the right of 9, it has the absolute value symbol on it. That's how you get absolute value. You'll have to scroll over all the way to the end of that row. You should get a graph that looks like this. It's a horizontal line going through y equals -1, and then another horizontal line going through y equals +1. Once you have that graph, you can pull up your table. So for -2, we get -1, and then -1. And then whenever I skip to when my x is +1 and +2, the graph jumps up to +1. So I'm going to use 2 different colors because there's 2 different graphs going on here, just like with that text message problem. I've got this left side of the graph, which is reflected in the top half of my table because the values are at -1. So whenever we create a rule, it's going to be with this left side of the graph. And then I have this right side, which is reflected in the bottom table values. And so we're going to use this second rule for that graph. Okay, let's start on the left side. So over here on the left, my equation is y equals -1 because all of my y values are equaling -1. Let me just go ahead and highlight it in green. And that's when x is less than or equal to 0. Because remember, if we're on the left side of the x-axis, all of my x's are going to be negative. They're going to be less than 0. And on your Google slide, it's actually kind of hard to find this less than or equal to sign. So why don't y'all just go ahead and just use less than or equal to. That way you don't have to mess with finding it. I'm not going to count off for that. Now let's switch and do the right side. So I'm going to highlight this graph in red. So on the right side, all of my y's equal +1 when x is greater than 0. So we just created two different rules to represent this function. And whenever you do this on Google Slide, you're going to fill it in just like I did. If you get this one wrong, you deserve it because we're doing it all together. All right, moving on to number 2. So we need to create a new graph to represent this function. I'm going to go ahead and pull up the table on mine. That way I can get some exact points to plot. So at -2, we'll get -3, then -1, -1, and then it switches to the other side of the graph. I get 0, 1, and 1, 1. So in green, I'm going to plot those 2 points, -2, -3, and -1, -1. And then for red, I'm going to graph this right side of the graph. So once again, my graph is split up into two different type of graphs. So for the first equation, we're going to go with the left side, the green graph. And I need to write a rule. Remember that we write rules for linear equations in the format y equals mx plus b, slope-intercept form. So we need to figure out what the slope and y-intercept is of this green graph. Well, my slope is positive because it's increasing from left to right, and it's going up. Remember, you got to do rise over run, up 2 over 1. So this would be 2x, and then my y-intercept crosses right here at +1. And this is for when my x's are less than 0. Because right here is where they meet, so everything to the left of that is when x is less than 0. Now we're going to do the equation for the right side, this red graph. So I don't have to put it in mx plus b format because it's just a straight line. So all of my y's equal +1 when x is greater than 0. Okay, so you're going to do the same thing on your own on your Google Slides. Just make sure you fill in each one of those sections and then turn it in.